AGL Corporation and Mobile Automation have formed a joint development company targeted to design for worldwide manufacturing and distribution a complete range of machine control systems for mobile equipment used in construction, agriculture, and industrial applications. For nearly 30 years, AGL has been developing, manufacturing, and distributing laser systems that provide control reference systems used in the construction industry for the control of gravity flow pipelines, construction of buildings, grading of building sites, and forming of agriculture farmland. Mobile Automation, Moba, has been supplying grade and slope devices to the paver and planer manufacturers throughout Europe for over 25 years. Their original grade sensors have become the standard mechanical stringline sensors for a majority of the European paving machines. Together, AGL and Moba, through AGL Mobile Automation, is committed to providing the finest total machine control systems in the world. In 1994, a revolutionary system for leveling the screed was developed. Due to its accuracy and its simple operation, the system became a great success within 1 year. The heart of the new system is the digital controller, which is mounted firmly on the outside of the screed. 4 different types of sensors are available for equipping the asphalt paver. The DigiSlope sensor for slope control. The DigiSlope sensor is equipped with a specially developed sensor for the paver. It enables slope control for very wide screeds as well as for high compaction screeds. This specially designed slope sensor has proven itself as it has been used for the last 20 years in the well-known S276A slope controller. The Sonic Ski sensor. For all applications, the Sonic Ski sensor employs contactless ultrasonic techniques. The use of 6 ultrasonic sensors enables a sensing width of 10 inches over the string line. For ground sensing, the Sonic Ski calculates an average value and will smooth out irregularities of curbs and gutters. The Digi-Rotary sensor for grade control. If the use of an ultrasonic sensor is not possible, the Digi-Rotor sensor is a good alternative for the money. The Digi-Rotary sensor works with the same principle as the proven G176B controller. As accessories, a sensing arm, a sensing tube, and a sensing ski are supplied with the Digi-Rotary sensor. The 360 laser receiver. The 360 laser receiver is used everywhere a rotating laser transmitter is employed as a reference. For example, laser transmitters are preferred for airport and parking lot construction. The digital controller recognizes the sensor, which is connected and is immediately ready for operation. The operation of the various sensors differs very slightly and causes no problem on site for the user. AGL Mobile Automation, the right sensor for every application. The standard system is installed on the paver in a few easy steps. The digital controller is installed into the standard holder. The cable of the digital controller is plugged into the machine connector. The DigiSlope sensor is installed on the transverse beam and connected to the digital controller with the coil cable. First, the controller is installed into the standard holder. Now, as with the DigiSlope sensor, the cable of the digital controller is plugged into the machine connector. The ski is installed and connected to the controller. Finished. How to operate the standard system. If the sensor has been installed for the first time, or if a sensor has been changed, the new sensor must be acknowledged by pressing any one of the keys. With the up or down key of the controller, the toe point is brought to the start position. To initialize the set point to be the same as the existing actual value, press the return key. The display now shows the actual value again. By pressing the AM key, the automatic controller system is activated. The controller now controls the set point displayed. During operation, the set point can be changed by pressing the up or down keys. The controller immediately adjusts the actual value to the new set point. With the sonic ski, the same procedure applies as for all sensors. If the sensor has been fitted for the first time, or if a sensor has been changed, the new sensor must be acknowledged by pressing any one of the keys. By simultaneously pressing both up and down keys, the stringline mode can be activated or deactivated. The illuminated stringline lamp is a confirmation of the selection made. The toe points can be set to the start point by pressing the up and down keys of the controller. For stringline sensing, the ski must be positioned perpendicular at a height of about 14 inches above the string line. This is signified when the actual value display no longer flashes. By pressing the return key after positioning the sonic ski, the actual value and set point are set to 0. After pressing the AM key, the controller works automatically. The set distance between the sonic ski and the sensed reference is kept constant. During operation, the set point can be changed to the required value by pressing the up or down keys. The sonic ski immediately controls to the new distance set. What should the ideal sonic sensor look like? It should allow working above the string line without any problems. Practice has shown that a 10-inch lateral shift across the string line is sufficient. In addition, 5 sensors are needed to calculate the value and to accurately control the grade while using a string line. Temperature variations should be compensated for by measuring the ultrasonic speed with the 6th sensor. Now it only needs to fit into the standard holder and work together with a digital controller. Add a nice color. And finished. Yes, that's what an ideal sensor should look like. How is distance actually measured with ultrasonics? It's simple. You need a sensor that can send and receive ultrasonic waves, a reference surface, and a stopwatch. The sensor sends the sonic waves in the direction of the reference surface and starts the stopwatch. The sensor is then switched over to receive. The sonic waves reflected back causes the stopwatch to stop when they are received. Once again, in slow motion. The sensor transmits sonic waves, and at the same time, the clock is started. The sensor switches over to receive. The sonic waves are reflected, received by the sensor, and stop the clock. Because the speed of the sonic waves is known, the time measured can be used to determine the distance between the sensor and the reference surface. But unfortunately, it is not quite that simple. Sonic waves do not always travel at the same speed. Their speed is dependent on air temperature. Sonic waves travel faster in warm air than in cold air. By making a reference measurement in which the distance is known, a sonic speed reference can be established. Please note that the reference measurement determines the air temperature of its own reference distance, not the temperatures outside this range. The greater the distance measured, the larger the measuring error. For a distance twice as long, the measuring error will be twice as large. And concerning errors, what happens in the string line sensing mode if the ultrasonic sensor does not detect the string line, or when ground sensing large stones hinder measuring? To eliminate such errors, AGL Mobile Automation has integrated a control window for the sonic ski. This window is normally set to plus or minus 1 inch. This value can of course be altered according to circumstances. The control window works as follows. Obstructions which are larger than the control window are ignored, and the controller stores the last value. If the control window has been set too small, there may be complications with large changes of the reference, for example on steep slopes. The control window itself is not designed to compensate for irregularities of the reference. This is done automatically by the sonic ski taking an average value. Systems that work with only one ultrasonic sensor light up in an area of about 10 inches. The reflected sonic waves first detected are taken as a true measurement of the distance. Unevenness of the reference is simply copied without correction. For ground sensing, the sonic ski works with 3 ultrasonic sensors. From the resulting 3 independent measurements, an average value is constantly taken. In this way, irregularities in the curb or the gutter are averaged. Not quite. When inspecting with a magnifying glass, one can detect small errors. But the sonic ski is still 3 times more efficient than a single sensor. Ultrasonic waves spread out in the same way as a cone of light. Sensors, which work with only one ultrasonic sensor, must be positioned about 30 inches above the string line. Only then, and very inaccurately, can a sensing width of 10 inches be achieved. Why very inaccurately? It's not always possible for the driver of the paver to keep one sonic sensor directly over the string line. With a 10-inch cone produced by a single sonic, one can have up to a 5-inch lateral side shift and still be sensing the string line. With this 5-inch lateral shift, there is a vertical elevation error of 1/2 of an inch. This is based on the Pythagoras theorem. Therefore, the sonic ski from AGL Mobile Automation is fitted with 5 sensors. For string line sensing, only one sensor is evaluated, the one with the shortest distance to the string line. Thus, an accuracy of plus or minus 1/16 of an inch can be achieved. It's not a trick. It's a sonic ski. If quality and accuracy are important to you, give AGL Mobile Automation a call at 1-800-643-9696.